Thank you. I'd like to thank you guys for coming to this presentation. I'm competing with Matt Johansson from White Hat. He's got a great prezzo where he shows off some denial of service attacks. I will show you how to defend. I'm the nice lady on that face. So, as we said, this is an adult presentation. Disclaimer, this is not an F5 presentation. I am not going to talk about F5. This is not HR friendly, and by any way, means, or not F5 HR approved. Who am I? I'm a security geek. I have 20 years of security. I have all these boring certifications, but I got somehow pulled into denial of service defenses with most major banks and stuff like that. So that's how I actually started researching this area. I'd like to give you a quote, or start with a quote. If everyone is thinking alike, then somebody isn't thinking. And that was sort of the quote and the inspiration that I took to do this research and to do this talk, simply because a lot of people act just like an army and try to think about DOS as just like one another nuisance, and it's not actually a nuisance. So let's start with the reason why I started this. All the banks have been attacked. These guys have actually on September 18, almost a year and something ago, they started to attack these banks. What was really interesting with this attack, this was the first time that the attack was organized. It was well funded, and another really, really important thing, they did extensive HTTP reconnaissance. Before this time, no one has done this, right? And how they've done it, it was really easy. You just use a crawlers or whatever you want to do, and pretty much it's just one big script line that you can use and browse the websites and collect the information from those websites. It's really simple to do HTTP reconnaissance, but it's really hard to detect who is doing HTTP reconnaissance on you. Really, really hard. I would say almost impossible. So how did I feel? I was very pissed because these banks were down. It made me look at ourselves and say, do these guys really can hurt us this much? Like, really? What are we doing wrong, right? So as every good, smart guy, or guy who's trying to be smart, I made a first decision. I said, I'm going to do some research, because this we have to see a little bit something different, right? So I looked at the PHP papers. Trust me, it's a good sleepless medication. You start reading those PHP papers, you fall asleep like this. You try to visit some hacker sites, and you can actually buy different types of attacks. For $20, you can attack JP Morgan Chase for 3 months, $20. They give you the IP. However, if you use the same tool to attack Bank of America, they'll charge an enormous amount of money to your credit card because you violated hacker contract agreement. So anyway, just so you know. I looked at the certain OWASP. It's more about process, and it has some validity, but we need to look at better things. I looked at other vendors, what they are doing. Our solution is the best. That's the song, right? I work for F5, so our solution is the best. So what were the findings? PhD papers proposed some solutions, but there was one particular that stuck to me. It says, we should really, really re-engineer the internet. Oh, really? Tell me about it. It's some good stuff. Hack SL code. Organizations are good with incident management processes. And vendors just list attacks. And F5 is to blame for that too, because we see an attack. Oh, we see Solaris. Oh, let's develop a protection for Solaris. Okay, I modify Solaris. I put Pez-Loris, right? Do we have a protection for Pez-Loris? I don't know. It's a new attack, right? Those are the types of problems that there is no protection mechanism. Someone has thought about how do we protect against any type of denial of service attack. So there is no structured approach. That was my finding. There is no one who's thought about this before. no open organization that actually works on this. A little information from victims. Banks were like, oh, we're fine, we're fine. You were down and you were fine. Oh, good for you. Also, there is a little cooperation. I'm from F5. I approached our board and I said, hey, guys, let's work together. We can make this work better. They're like, go away. So those are the types of things that I come across in my life. So pretty much, I felt like this. I was chasing my tail, or I felt like this. I was like, God will never do anything. So as a good engineer, I decided, okay, let's do something better. Let's do it yourself mode, right? Try to do it yourself. So I peeked over the fence and so tried to see what other guys are doing. And I discovered that they are doing denial of service signatures. And this is really, really not good. As I said, slow Loris, Pez Loris, Kelly Loris, whoever he wants to, if you change the signature, they will never detect you. So this is the problem that we have in industry today. What you are trying to do is constantly push uphill. And I was like, let's step back and let's try to find a method that will actually help you not fight like this, right? Because this is exactly what we are doing. So idea, DOS attack classification. How I did this. So I started collecting the attacks. Anything that I can find out there on the internet. Layer 2, layer 7, all the attacks like ping of that. Who remembers ping of that here? Famous Windows 95, right? I personally am not guilty of using it. Collect denial, analyze how these attacks are attacking you. So what is the vehicle? What is the end target, right? Because the purpose is to find the target, classify those targets, and then verify the classification and do it all over again always. So idea is to use classification. Instead of developing against hundreds of attacks or any new attack that shows up, what we are going to do is develop protection for few classes, right? Protect the target. That's the idea. Protect the target, not protect against a single attack, because tomorrow there will be a new attack that will hunt you, right? So these are the things that we really need to do. The other thing that we achieve when we have a classification and when we develop protection mechanisms was we don't have surprises. It's a large sample of attacks that we analyzed. It's a large quantification of attacks. And if we develop those categories properly, every new attack will fall into one of those categories. And we will have a DOS protection mechanism. So I felt really good, or more like this. It was like, so let's start and get to developing the attack protection. I have collected over 100 different attacks. I analyze attacks mechanisms, and look how they initiate DOS. So pretty much today, these are the categories. Volumetric, so let me step back. This year at DEF CON, some other guys have also attempted to do the classification, and in industry you will find volumetric, this is a clear, we send a flood of data, flood of something. And then there is something which some people call asymmetric, and the guy who, the famous guy who wrote the book about asymmetric attacks is calling them asymmetric. I tend to divide them to two. One is stateful-based attack, which abuses your timeout or a session state, like slow Loris, right? Slow Loris doesn't need a lot of bandwidth, which just connects and exhausts your connection table on your network stack, and you're done. You cannot serve it. Computational, like SSL renegotiation, where I ask your CPU, give me the keys, your CPU is just crunching the keys, never completes that, and as a result, it stops serving your application, right? And then you have vulnerability. Vulnerability such as Apache killer attack, right? Or a Plesk zero-day attack, right? So those are the types of attack that you can do this with. And also, of course, there is also and always what people call blended or diverse distributed, I call them triple D attacks. And that's pretty much flood plus session state change abuse. Combination of the two types, right? Either a flood with something else, right? Flood and SSL renegotiation. Actually, one bank got hit with ICMP flood and SSL renegotiation. While they were dealing with ICMP flood, SSL renegotiation brought the service down. So let's look at some of the samples of attacks. These are the samples of attacks. These are the tools that you can buy on the internet. Titles of the tools. You will see none where there is no tool, but you just have a code. And these are the sort of protocols that you attack, and these are the sort of what are the vehicles for those attacks or the targets, right? What do you do with this flood, right? DNS reflection amplification. I ran out of room, so reflection amplification is not the same attack, but it's good. So if you want this list, that's something that approach me later. So these are the stateful attacks, pretty much slow and low attacks. Slow get, slow post, slow low risk, zero window, slow responding URL, right? Those are the types of attacks that you will see as your slow attacks. Again, they exhaust your connection table. So we have a computational, and these are the attacks which are XML DTD, XML external entity, SSL renegotiation, crafted header, where through header I actually issue a command and your web server starts calculating and pretty much stops serving your application. Vulnerability abuse attacks, a particular hash DOS attack, buffer overflows. Yes?
No, it's like listening to old records here. I can see some old historical stuff.
Yeah, there is old stuff here. Ping of that is another one. I said I just put the samples together and so that I can actually do the classification of attacks. Why? I need this classification to develop protection mechanisms. So distributed denial of service, you have SYN flood, slow low risk. That was one of the attacks, and then SYN flood and crafted URL. So when they do a URL reconnaissance, they craft URLs that are actually responding slow, and it's also a stateful or computational types of attacks. So we're getting somewhere. I can see sort of the light at the end of the tunnel. So we're going to go back to protection mechanisms. Again, safety guy. How do we develop protection mechanisms for volumetric types of attacks? For volumetric types of attacks, you have different offerings, but DOS as a service is one of the offerings where you spread the attack over the internet. And pretty much what you want to do with volumetric attacks, keep them out of your data center, deal with those at the perimeter, right? You can do BGP. You can use redirects. There was a talk this year at the Black Hat. If you are using cloud service, DOS as a service, and you are using DNS redirects, it's a really bad idea. You do not have DOS protection if you do that. So make sure that you verify with your cloud service provider what you are trying to do, because I can attack your IP directly, and it will completely bypass this cloud service. Session resets, rate limiting, insert client protection, verification. How does that work? When you get a flood, you want to know which sessions are good, which sessions are bad. So have a tool that actually inserts some client verification check, whether it's a browser or a botnet, right? That's something that you should be doing. But in general, you try to keep this at the perimeter. So look at the stateful protection, right? How does stateful protection attack work? These are really, really, really hard to protect. What does it abuse? It abuses your timeouts, right? Because it abuses your timeouts, you have your network systems, web servers, your web applications. Apache default timeout is what, 30 minutes? 30 minutes. How many sessions can I generate within 30 minutes? Ton. So it is really, really hard. What we have found that it's better if you have a proxy-based firewall or your application delivery controller that sits in front of your applications. You can use it as a tool that actually can control the number of connections that are being established towards your servers. So it takes a little bit more of capacity planning, and it takes more of calculations on your behalf. But to protect against these types of attacks, you should be able to control number of connections or concurrent connections that you can handle with your infrastructure. That's the basic idea. Yes?
Where would you recommend getting the data for the timeout values for the tooling?
So you start from the front, your firewall at the beginning, like at the perimeter. Then you start to do your IDPS. You start with your proxy or application delivery controller. You start with your servers and anything in between. So you need to align them. The biggest problem here is that your firewall, your ADC, your server can handle different numbers of connections, right? Concurrent connections. That's a really, really important thing, because why firewalls fail over when this attack, when slow low risk happens, who falls down first? Firewalls. Why? Because when you have 150,000 concurrent connections, no matter how you configure the firewall, their network stack is going to be busy. They go down. They stop serving packets, right? So those are the types of things that you can do, and have a mechanism somewhere on your network where you can remove all the session first. So you should be able to have a timer and say, if the session is older than 5 minutes, I'm going to clean it. I don't care what it is. Clean it. And for and if you build that type of a protection, you don't care, is it a slow loris, is it a PES loris, or is it a slow post, or whatever type of slow attack you have. You have a good protection mechanism. Another one is for your computational. And this one is really, really hard. XML DTD attack is the one where I send the calculation to your web server. Your SSL renegotiation, this is something that you will really, really need to think about. But there is no real protection mechanisms for these ones, right? Because it's a normal request, it's a normal application request. I ask your web server to do something, and web server does it because that was what I asked it to do. So you really, really need to analyze your environment. Another one, and it's, again, a simple solution. That's why you have your application delivery controller. That's why you have your proxy in between. This proxy can actually offload SSL, and this is where you can control your SSL. Also, this is where you can actually implement XML protection. This is the area where your WAF can be used for your denial of service protection. Web application firewall can be used for that. Why? If you go back and say, you see here, XML DTD attack, there is no denial of service solution that will detect that attack. Only web application firewall will, right? So your WAF combined with these things will actually help you. And this is where people don't think, but if you have a WAF, that's another tool for you because it prevents these types of attacks and the next type of attacks, which is vulnerability types of attacks. So vulnerability abuse attacks, right? Vulnerability abuse attacks are the ones that we have to develop good application code for. And that's, I think we all do this. Right? The recent Plesk vulnerability, Plesk is a web performance measuring tool. I don't know, it's free, open source. Well, they had a zero-day vulnerability where you can issue via PHP script a system command, right? So it was really, really good. Anyway, this is something that you need to protect from, and this is where your web application firewall is getting the place. So if you use scanner, web application, like White Hat application scanner, scan your application. Use your WAF to protect you against denial of service. It sounds contradictory, but it's true, right? Attacks such as Apache Killer, if you don't protect it with your web application firewall, there is no way you can protect it. And yet the purpose of that attack is just to bring down your web server. So we have done this for distributed denial of, I call it triple D, or blended denial of service attacks. You have to develop protection for all 4 types of attacks in the first place. Second, you have to develop a good detection mechanism. And third, you have to have a good incident management process. Once you detect it, you really, really, really need to have a good alerting and stuff. This is where OWASP practices are coming into a play, big time. Make sure that all hands are there, business, IT, vendors, every vendor should be there and should be helping you. So out of all these talks, let's do some like stepping back and looking at what we talked about. So for volumetric attacks, you want to keep them out there. You want to keep them at the perimeter, right? As far as you can from your pipe. ISP, DOS as a service, rate limit, BGP redirect, any tool that you can use there is good. However, this guy here must be able to handle first 10, 15 minutes of the load. Before your DOS as a service kicks in, this firewall has to handle the load, right? This is something that you really need to measure and properly architect for. And the other side is your in-house, internal, in your data center. And you see 3 types of attacks. We have here stateful, for slow, low and slow, slow or slow post, those types of attacks. These computational, such as SSL renegotiation, and vulnerabilities such as Apache Killer, right? Those types of attacks are something that you really, really need to protect within your organization. So make sure that you have a proxy firewall of some sort, or use your application delivery controller, whatever it is, to tune the connections, do the SSL offload, make sure that you do the, have a capability to address zero-day attack, to address vulnerabilities, scan your applications. Sounds funny, but for vulnerability denial of service, I'm not looking, I might be entering SQL injection, but not to steal your data, but just to bring down your server, right? And that's something that people don't often think about. So, and then you have at the back your applications and stuff. So this is your total protection. If you have all four of these, I warrant you, you won't get any problems with any DOS attack, for sure. But if one of these is not fine-tuned, you're gonna get screwed big time. So, incident process management for ultimate denial of service protection. Again, standard process, people, process, technology. I'm not gonna bug you much with this, but this is something that you really need to have for denial of service protection. So, we talked about types of attacks, we talked about how to protect, what is the best architecture. Now we're going to talk about lessons learned. What did we learn from our previous attacks, and why am I here to talk to you about? What I've learned is a lot of vendors, including my company, will tell you we do everything. And that is not true, actually. I wonder why is that not true. But I've came across recently guys that do a lot of denial of service as a service, or content delivery networks wanted to sell their solution as a denial of service solution. And if you buy that solution, this content delivery network or IDPS solution, you have a problem with 3 types of attacks. And the attacks are listed here. And if you want me to get you more, I can, but these are the most popular ones. So your content delivery network, as we said, should help you protect against the attacks that are out there at the perimeter. Why? Why is that? For every single of these attacks here, slow post, slow get, for this crafted URL, you have to understand every single application session. That's the biggest problem. When you're out there in the cloud, do you know what's the state of the application in your data center? Of course not. And if they tell you that they know, they lie outright. The same way as I would say, oh, F5 knows really well how to protect you against volumetric types of attacks. No, we don't, right? So those are the types of things that really, really think about when you are designing your denial of service solution. And those are the types of things that I'm sort of trying to cover here in your general terms and approach, where these are the types of attacks, and this is where you position your defense mechanisms, right? And you don't care, again, the benefit of this is you don't care, is it a new attack or an old attack? There was a huge hoopla this summer. Oh, there is a new dirt jumper, blah, blah, blah. What is a dirt jumper? It's an HTTP flood attack, period. Oh, it's a flood attack. Do you have DOS protection out there? Yeah. I don't care if it's a dirt jumper version 2, or it's called September, or it's called dirt jumper. I don't care. The target is the same. I have mechanisms that are built into my infrastructure and my technology that protect against that. Done, right? Very simple. I can sleep at night then, right? Invest in both perimeter and on-premise. If they tell you my perimeter thing solves everything, no. Build a DOS resilient tiered architecture. Make sure that you have tiers, front tier, perimeter, and back tier at least. Mitigate layer 3 and layer 4 attacks with rate shaping, snot pool, some flood control. Mitigate layer 7 attacks with secondary tiers. So what some of the guys that I work with have done is they have an application, it runs into 2 data centers, they got attacked. What they started to do is, oh, okay, now I'm going to introduce CAPTCHA, right? It's an additional control that weeds out botnets from a real browser or a real user, right? And you can instigate it like this, where on your web application firewall, on your proxy firewall, on your application delivery controller, all these things. So see what you have in your infrastructure and implement this. It's a good, simple protection mechanism. Blacklist, people like to use blacklist. And this is something that I'm not really a fan of. I never recommend it. This is only as a last resort. There is stuff like Webroot sells IP intelligence, where you can detect where the people are coming. There is about 9-10 categories: botnets, denial of service, anonymous proxy, IP addresses. And if you subscribe to that database, you can say, oh, now I'm going to implement IP intelligence database when the attack starts. It's way better than just creating your own blacklist, which can eliminate a lot of users, right? And you want to serve good users. You don't want to stop the service. Another thing that I would like to point here is don't do denial of service tests like this. Oh, I take my laptop, get slowloris.pl script from the internet, I run slowloris, and then I check whether my denial of service screams, oh, it's slowloris. Guess what? In real life, that will never help you. In real life, what you need to do is to simulate real life, generate a good traffic, and then generate ton of attacks towards your infrastructure and see whether you can still browse your own website. Because that's the success criteria. Success criteria is, can I browse my website while I'm under the attack? Not, oh, I detected it screams it's slowloris, right? That's not the purpose. The purpose is, I gotta serve my customers while I'm dealing with the attack, right? That's how you should be testing your DOS solutions. So one part of the runbook, create your own runbook. So what we've done, at the beginning it was like, in September 18 or 19, it was like, there was 100 people at every single bank and they were all looking after everything. Today it's like 2 or 3 individuals. Well, attack is happening next Tuesday, we know about it. And we have procedures, we know what are we going to do. We have different controls that we put in place. Either perimeter and stuff, we tell our ISP, hey, you better watch after this and stuff like that. So it was really, really good experience. And today, what they are doing is actually really process-driven and really ironed out. Make sure that you have all these addressed in your runbook or guide how to protect against DOS. It's really going to help you. So I think this is all about experiences. The decision that was made, I have, my consumers are large banks and they always scream at me. So I was like pushing back and I was like, okay guys, help me help you so that I can actually give you some real background. And the reason why I was screaming that was, there is no alliance for Open DDoS. Were you attacked? No. Are you good? Yes. Oh, are you sure? You were down. That's not a really good state, right? So if you do connect with vendors, start an open alliance. It's your power to call and say, F5, what can you really do to help us against DDoS, right? Arbor, help us. Prolexic. I have customers who are like, oh, we bought Prolexic. I'm like, okay, let me run some couple of attacks against your, I single-handedly, from my laptop, will bring down your service. No, you won't. Okay, well, do you want to bet? Usually win the argument. Make sure that you integrate with the technology, we integrate with vendors. Be more proactive because it's about your environment, right? So what I'm preaching for is Open DOS Protection Alliance. It's big, sort of part of the OWASP body. There is a denial of service thing that is being studied up, but please open up and act. Today, as my brother from the other side, the keynote said, it is not a game anymore. When they attack you, they know your website. They've done the research, what they can do. One of the banks has a capability to, you can find where is the closest ATM on their website. But that takes time and a lot of resources because it's poorly written. Guess how they got brought down? Someone was searching for ATMs all over the world. So searching for an ATM in China, and the site was calculating where is the ATM in China. Anyway, just so to, like, there are application logic things that you have to think about. So one thing is, if you want to test your stuff, OWASP has a good tool. I think that this is a little bit older, version 3.6. I think that there is a newer one. I have it on my laptop. I was like, okay, let me check your services, whether they work really, right? It's a really nice handy tool. There is a NOVA's project, security ecosystem project. After the banks got attacked, this body is sort of association of all the big banks in US. And I was fortunate to get into the meeting, but it's a closed door meeting. And the reason why we were invited was to see which vendor they can blame. And it was a closed door meeting, and they are still doing it closed door. And I said to them, guys, if it's a closed door meeting, you will never go anywhere. Something like, again, the keynote guy mentioned, you cannot provide fee input because you are not a bank, or you're not a banker. Anyway, let us feel like we're champions. We can make this happen, right? We can really make this happen. Use these 4 categories. It's really going to help you to build your architecture. And I wanted to also raise some stuff. Don't just attack people with your laptops. Ain't going to go well for you. And this is an example. And she actually was freed. But I just want to point to this. If you block the traffic on the street, it's a $200 fine and you spend the night in jail. If you DOS someone on the internet, you can end up in a prison for 15 years. Something to think about. But yet, it's still happening, right? I want to leave you with this quote. Whenever you fight on the side of the majority, it's time to pause and reflect. Step back and say, okay, what am I doing wrong? Or am I doing something that I have no clue about, right? It took me almost 5-6 months to get to all these types of attacks. And the reason why I have 4, not 3, is because you really have a different protection mechanisms for this specific target. And this is what you need to actually look after and protect against. So that's all from me. Any questions? Feel free to shoot. It's a pleasure. Thank you for coming. And if you want a copy, let me know. You have my email. Shoot an email to me. I travel. I don't use phone. I just use email. Thank you.